Ever wondered how AI can figure out what students really know about coding? Or why some learning tools miss the mark when students make mistakes? Today, we're diving into a breakthrough that's shaking up how we track learning in programming by cleaning up the noise that trips up traditional systems. Let's start with the problem. When students code, they don't just write perfect solutions. They experiment, debug, and sometimes submit noise, like incomplete code or random guesses. These distractions can trick AI models that try to map student progress, making them think learners understand concepts they don't. It's like trying to read a book with pages missing or scrambled words. The solution? A new approach called Denoising Programming Knowledge Tracing. Think of it as a smart filter that separates the signal from the noise. Researchers built on earlier work like CodeNet, a massive dataset of code, and models like Code-DKT that track knowledge over time. But here's the twist. They added a code graph to visualize how code structures connect, and an adaptive tuning adapter to adjust for errors. Here's how it works. Imagine coding as a maze. Traditional models might get lost if a student takes a wrong turn. This system maps the maze using a graph, like a roadmap showing all possible paths. Then it uses math, don't worry, we'll skip the equations, to tweak its predictions, ignoring random guesses and focusing on real learning patterns. It's like having a GPS that learns from every wrong turn to guide students better. Let's break down the key components. First, the code graph, a network where each node represents a code submission and edges show similarity between them. This helps identify outliers, like that random, "Welcome to KDD 2025, submission that's unrelated to the problem. Next, the Graph Convolution Network, GCN, acts as a detective grouping similar code changes. If a student swaps a variable name, the GCN flags this as a weak signal, a minor tweak that doesn't reflect true understanding. By filtering these, the system focuses on meaningful progress. What makes this research stand out is how it builds on decades of work in AI and education. From early gradient descent algorithms to modern graph-based learning, each step brought us closer to models that adapt like human teachers. And as coding becomes a core skill, tools like this could revolutionize how we learn and teach programming. The results? This method outperforms older models by handling noise more effectively. It's especially good at catching when students are on the verge of understanding a concept, but haven't quite mastered it yet. For educators, this means more accurate insights into student progress, no more false alarms about knowledge gaps that aren't really there. So next time you're coding or learning something new, remember the invisible work of tools like this. They're cleaning up the noise so learning can be way more effective. Thanks for watching. If you're curious about how AI is reshaping education, hit subscribe. And let me know in the comments, what's your biggest coding challenge? Maybe we'll tackle it next.